Hello, my name is Sebastian Martins, and together with Patricia Pesado and Ramon Garcia Martinez, we present the article Information Mining Projects Management Process in the 28th International Conference on Software Engineering and Knowledge Engineering. The presentation is structured by 6 sections: Introduction, where we present some important definitions and events; States of the art, where we briefly describe the most relevant existing process models; Address problem, where we highlight the issues identified; Process model (MOPRP), where we present the general structure of the proposed solution; Discussion, where we make a comparison within the process solution and existing approaches; Conclusion, where we summarize the result obtained and propose the future reschedule. The term data mining is strongly bound to the concept of large databases and goes back to the definition of searching algorithms of knowledge patterns. However, today there are research lines in such fields such as text mining, image mining, pattern and information stream mining, web mining, among others. In this context, our research line considers appropriate to use the term information mining as a generic reference to any of the aforementioned type of mining. Based on that, software engineering has been defined as the application of a systematic, disciplined, and quantifiable approach to the development, operation, and maintenance of software and the study of these approaches, that is to say, the application of engineering to software. It's agreed to define information mining engineering as the application of a systematic, disciplined, and quantifiable approach to the development of information mining project and the study of these approaches, the application of engineering to information mining. From this perspective, information mining engineering focuses on defining procedures to guide the development of information mining projects. Its main objective is to identify interesting patterns and relevant pieces of knowledge to the organization, ensuring their correct understanding and providing reliable support for the decision-making process. To achieve this goal, it is necessary to establish a set of activities that provide an overall project structure supporting the development process. This guideline should not only define the development aspect, but it also must define those management activities associated with the project program. Throughout the last year, there has been a sustained effort to define a process model to guide the information mining project. The most relevant results are: in 1996, Fayad et al. Defined the first process named knowledge discovery in databases, whose aim is to provide a set of tools to systematize data mining process and the artisanal process of hypothesis selection. The underlying objective to the concept of knowledge discovery in databases is to differentiate the term data mining, understood as the activity of applying different algorithms on data in order to obtain patterns that the process needed to generate knowledge from data. That is, understanding data mining as a sub-element that integrates the general process of obtaining knowledge patterns. In 1998, the SEMA methodology was defined by the SAS Institute as the process used to reveal valuable information and complex relationships in large amounts of data. Its name was defined from the acronyms of its steps: sample, explore, modify, model, and assess. In the 200, Chapman et al. Defined cross-industry standard process for data mining. It is a widely used methodology focused on the development tasks involved during the whole process, considering slightly some activities related to the management of the project. In 207, Marat et al. Proposed an integrated approach essentially composed by 3TM and the standards developed conventional system IEEE 174. It also incorporates an element from ISO 1200 2007 and 1500 5004. The steps involved in KDD are: learning the application domain, includes relevant prior knowledge and the goal of the application; defining a target dataset where discovery is to be performed; cleaning and processing, include basic operations such as removing noise or layers; strategies for handling missing data files; data reduction and projection, involve finding useful patterns to present the data depending on the goal of the task; choosing the function of data mining, includes deciding the purpose of the model derived by the data mining algorithm; choosing the data mining algorithms, matches a particular data mining method with the overall criteria of the KDD process; Data mining includes searching for patterns of interest throughout applying the data mining algorithm. Interpretation includes interpreting the discovery pattern as well as possible visualization of the extracted patterns, removing redundant or irrelevant patterns and translating the useful ones into terms understandable by users. And finally, using discovery knowledge includes implementing or documenting the result. SEMA consists of 5 stages: sample the data by creating one or more data tables, explore the data by searching for anticipated relationships, anticipating trends and anomalies in order to gain understanding and ideas, modify the data by creating, selecting, and transforming the variables to focus the model selection progress, model the data by allowing the software to search automatically for a combination of data that reliably predicts a desired outcome, and assess the data by evaluating the usefulness and reliability of the findings from the data mining process. The phases that make up PCDM are: business understanding aims to comprehend the objectives and requirements of the project from the business perspective, as well as identifying the data mining problems and perform the project planning. Data understanding starts with an initial data collection and proceed with a data analysis identifying the data quality problems and possible interesting subsets to apply different hypotheses. Data preparation covers all the activities needed to generate the final dataset from the raw. Modeling covers the selection, configuration, and implementation of various modeling techniques. Evaluation: the build model is analyzed to ensure the business objectives are accomplished. And finally, development covers those activities oriented to integrate or to document the knowledge gained. Joint process model takes the IEEE standard, modifying only the development core with the phases identified in CRISP-DM, and incorporates the process of acquisition and supply from the ISO 1200-2007 and the organizational process from ISO 1500-5004. After more than a decade using process models focused on development activities, several researchers highlighted difficulties in the existing process model. Additionally, it was pointed out that the failure rate from this type of project was greater than 60%, being CRISP-DM the main methodology. Some of the deficiencies that have been identified are: they do not contemplate or partially contemplate management activities and their corresponding techniques or tools. They have a static structure, making it difficult to adapt the project based on the characteristics of the business, and performing extra iteration because they do not foresee dependencies between activities. From the analysis performed, arises the need to define a new process model for information mining engineering project, focused on discovering relevant pieces of knowledge to support the decision-making process, which incorporates the management vision required to successfully achieve the development of this kind of project. The proposed process model, called MoPropay, consists of 2 sub-processes: development and management. The development process is a version base of CRISP-DM which reduces iteration necessity, modifying the order and structure of the activities, and includes a set of tasks such as business and problem modeling, deriving the information mining process, among others, in order to facilitate the comprehension and implementation of a project as well as the quality level of the resultant products. The management process for information mining engineering projects provides a transversal layer to the development process, which offers several mechanisms to improve the quality and maturity level of the resultant product and process. Additionally, this sub-process incorporates different tools developed over the last year by the research group in order to cover the existing gaps. The tools developed are techniques belonging to some of the activities of management sub-process. In 2008, Britos et al. Described a framework with defined tasks required for elicitation of requirements and proposed a reference model for identification and documentation of relevant concepts to carry out an information mining engineering project, along with the correlation between these concepts. In 2013, Pitel et al. Defined cost and effort estimation method for information mining project. This process describes the characteristics and analyzes the possible values over which the effort and cost required to complete the project are obtained. These features are divided into three categories, according to the origin of the data to be analyzed: factors related to type of project, data, and resources. Also in 2013, Basso et al. Defined a set of metrics applicable of information mining engineering process, grouped by three categories: data, models, and project. In 2015, a method oriented to determine the project feasibility is defined. This procedure identifies a set of characteristics to evaluate, which are classified in three categories: plausibility, adequacy, and success. From these criteria is determined whether the project is feasible, if information mining engineering is the best solution to the problem, and whether the results can be useful for the organization. The management process occurs as a supporting element to the development process, in which the execution of its tasks is not linear, but is made based on the progress of the project. This sub-process, structured by three additional levels, phases, activities, and tasks, provides a higher level of granularity. It consists of 5 phases, each one composed by several activities, identifying a set of tasks with a common goal. The figure shows the phases are comprised at the left of the bracket in the picture, and for each phase the activity associated and their existing dependencies, in curved rectangles and lines respectively. In the top and bottom of the figure there are activities from the development process, and inside each one is identified the phase and the activity name which belongs, upper and lower section. Arrows represent the interaction between two activities, dependent documents. There are also two types of line ending in point, solid and dot. Both represent an input document to an activity, which is produced by the team or the client respectively. The first phase, named Initiation, contains 4 activities. Communication protocol aims to determine formal channels of interaction according to the actual possibilities among staff and experts in the business domain. Exploration of initial concepts, where the team makes a first approximation to the client characteristics and their needs. Assess the situation, analyzes the project characteristics, client requirements, existing risks, and possible contingencies to determine the feasibility to the project. And finally, life cycle definition, determining the structure and iteration of the project, in order to encourage the development and success of the project. The second phase, planning, is composed by 3 activities. Activities planning, whose activity is to select and to determine the time required to finish each task of the project. Resources planning, its main purpose is to determine what resources are required and when, including outsourcing possibility. Estimation and responsibilities, where the time and cost of the project and the scope and obligation of the parties are determined. The support, composed by 3 activities: life cycle management, whose objectives are to formalize the scope of each project iteration and to establish the reached achievements, readjusting the scope of the next iteration if necessary. Implementation management covers those activities related with the development of the product, such as defining the objectives to be performed in each step of the project, integrating the internal product, and communicating the progress of the project. And configuration management, which aims to document the relevant information produced throughout the project. The phase of controlling and quality involves 4 activities oriented to improve the maturity of the project and its products, and keeps tracking of all the elements required to complete successfully the project. Resources control, whose aim is verifying the accomplishment of the planning made regarding the incorporation of resource, material, products, and human. Measurement quantifies elements of interest for the project analysis, using as input the metric list and the cost of the project. Activities. Activity control evaluates several project characteristics such as progress of activities, time, cost, possible risk, quality, among others, in order to identify possible deviations that jeopardize the successful development of the project. And finally, changes management, which covers all activities aimed at evaluating, implementing, and monitoring the changes required for the project. The last phase, formal closure, is composed by 2 activities: Formal external closure aims to ensure the achievement of the objective required by the customer, ending with the commitments between the parties involved in the project. And formal internal closure, whose objective is to obtain useful knowledge from the characteristics analyzed throughout the project in order to be reused in future ones. The table presented summarizes the gap in the previous processes, identifying whether the set of activities required for a project, grouped by the phases proposed in Mopropay, are full, partially, or not covered at all. The proposed model, mainly focused on developmental activities, have more than 15 years in the market and have been applied in large quantities and varieties of projects. In recent years, many issues and deficiencies have been identified. Neither KDD nor CIMA nor CRISDM define a process model focused on the management and control of the project. From this point of view, our proposal attempts to cover this vacancy. Furthermore, both KDD and CIMA do not consider activities targeted to project management, only focusing on the developmental activities associated with business and data understanding, data selection and processing, implementation of data mining algorithms, and analysis of results as pieces of knowledge. Although CRISDM identifies a set of activities related to the project management, including risks and contingencies, produce project plan, costs and benefits, plan development, plan monitoring and maintenance and review project, it lacks other extremely important features associated with the maturity level and success rate of projects. Marvani et al. In their joint process model define a scheme that is identified from the missing activities of their predecessor which software engineering activities could be applied. However, they do not clearly define their objectives, scopes, input and output, and possible techniques according to the objective of an information mining engineering project. Our proposal differs from this approach in that it's conceived considering all the general objectives of the project, extracting reliable and relevant pieces of knowledge to support the decision-making process, and it attempts to deepen those aspects that are not defined in Marman's proposal, describing in detail processes, policies, activities, tasks, input, outputs, techniques, and their goals. The contributions provided by the proposed process against previous approaches are: we propose a process model composed by two subprocesses, development and management. The management subprocess is conceived as a transversal layer to the development subprocess, which the discipline has been focused on throughout its history, and it aims to cover the current gaps in the areas of control and project management. The process integrates a set of tools created ad hoc oriented to reduce the risk and improve the maturity and quality level of the process and the resultant products. The structure of management subprocess is described identifying the set of activities required for an information mining engineering project, detailing each activity objective and dependencies, input and output. The activities are grouped into phases from the similarities in their goal from the overall process. We identify as future research work, extend the set of available techniques for different management activities, such as for the phase of requirement elicitation and analysis, and evaluate how the proposed model can be used to reduce risk and improve productivity. Developing experiments to compare the effectiveness of the proposed process model against CRISDM. Thank you very much.